Okay, so today we're gonna today we're gonna go over some vectors and then some projectile motion. So the first one that we have is an airplane traveling 235 kilometers in a direction. That is 41 west. The mnemonic that I have for the direction of the vector. Sucking waffles or wafers, whichever you prefer. And then you do that clockwise. So, oh, this is just a problem, because you guys need to see it. So I have it drawn out. Have the direction that we have the law communication. You could convert that how the question later asks how far to travel after 2.5 hours. So as long as you make note of the units, you should be fine. So we're gonna cut this down to the two components. You've got it. You've got this 41.5 degrees. And then you've got this obviously heading into the plus direction or north. I'm dividing my axis. Positive, this is the positive, this is the negative. The normal go back to the see. Make sure you define it somewhere. Because it's the so then the choose your B. It's gonna be your V. You can do N, I'm gonna do Y. And then this is going to be your VX. Now, I know she did a weird thing with angles where it's like straight, so then you're going to add that total angle where it's 90 degrees plus 41.5 degrees. But that's valid, that definitely works. A little side note on that, you're adding it to whatever line is closest to you. You have it down here. Right, you're gonna go it's 90 degrees here, plus it's 90 degrees here, plus whatever angle it is here. However, if you are instead same line, but your angle is told here instead of here, so then you can go to the negative y pattern, then you can either do 360 minus that angle or 90 plus 90. 90 plus 90 plus 90 minus this, minus 1. Because you're going that far. It's going to be plus 3. You're going that far. Basically here, I believe it's all counterclockwise. You're going this way, then it's going to be adding it, or if you're already going adding 90 plus 90 plus whatever this is. Subtracting from there. Anyway, pass that chat tangent. The way that I do it is I just keep the angle straight up, and then I have to double check that it's positive here. We know that this needs to be positive because it's going in the positive direction. We know this needs to be negative because it's going in the negative direction, right? So now we can do our trigonometry. We know that we have toe to toe. And what this stands for is sine. Opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And then tangent is equal to opposite over adjacent. So what does this mean? You have your angle, I'm going to draw it like this here. Okay, so this is the hypotenuse. Our hypotenuse is always the angle that's opposite from your 90 degrees. And then you have this angle, which is your angle. Opposite to that is this, which would be your VS. And then adjacent is the one that is touching. So this. Okay, so for the VX, you're using opposite. So VX, adjacent is VY. So these can be written as sine theta is equal to VX over V, right? Because this is our V, our hypotenuse. And then also for cosine theta is equal to the base, which is Dy over V. Okay, from here, you just multiply both sides by V. That cancels this one out. And adds it to the side. So I have V sine theta. Yes. And then you have the cosine theta and you go to Vy. Cool. From there you just plug it in. Just plug it in. You know that your V is this one. This is theta. So then yeah, you right in. You have 835 kilometers per hour times sine 41.5 degrees. That is your answer there, and then you plug it in for. You are in degrees, so you want your calculator to be degrees. Let me see if I can show you guys that on my screen. Okay, so see I have my calculator here. I'm gonna go into here, science, and this DRG, and then you're gonna check degrees, radians, and I don't know what that is. If you see a pi symbol in your angle, you're going to use radians. If you don't, and if you see that little circle, then you're going to use degrees. So the one that's underlined is the one that it is. Sorry, this isn't here. So then you just switch by like moving it over, like using the arrows. So I'm going to go with degrees. I'm going to hit enter, and then I'm in degrees. And you should say it right at the bottom here. Degrees. Cool. Equal to 553.3 hours. The sine and cosine doesn't change the units. It just is a multiply. So 625 minus 30.4 per hour. Then it asks how far does the plane travel after 5 hours. Here we're just gonna do. We're going to use V delta x over delta t. Move the t over there to give us V delta t equal to delta x. Right, so then VT is just equal to. We can do this. It's one of the ways you can derive your equations. You also know that your x not zero. I'm going to put in kilometers because that's what we have for our velocity. So then I'm just going to do 553.3 kilometers per hour times 2.5 hours. And then you can probably convert it over to kilometers to meters. I'm going to do it later. 5.2. Because I got a bit more space on this one, I was going to convert kilometers here. Remember, we just hitting to the side, but you have your kilometers here, gonna go 1, 2, moving backwards, or like inwards. So then you're going to be adding 0, or moving the decimal for 2 places. All good to it. This one's moving it, and sorry, this one will be moving it. This one will be not multiplying. So then we have 1 kilometer at the bottom because kilometers is bigger than our base unit meter. Then we're gonna add 3 zeros to the meters. That'll cross our top there. It's gonna be kind of big. I don't know how to say that. Sorry, this one is 1,000. 83.3 kilometers. And then remember we moved decimal over. We moved it that way to get the that way again. Yeah, kilometers. How much is it, right? 1, 2, 3. Add 0 to where we moved it, and then we can add it to kilometers there, and that's meters. So that's the end of that problem. I'm gonna go ahead. Oh, that video's still on. I'm gonna go ahead and share my screen over here. There it is. So we're gonna do this ant problem. You can start reading it while I figure it forward. No, stop a good time to pause it and turn this on. Back over. So we have an ant. It's on a graph table to make it visually appealing. But it goes 10 centimeters in the x direction. We're gonna assume positive x, no matter what direction it goes, you can set it as positive either way. So we're gonna go 10 centimeters in the x direction. So positive x. And then it's 10 centimeters. I'm gonna remind you this is something that you did in geometry probably. That's something just means everything, any line with those markings is the same. And then that's 2 seconds. From there, it turns left 30 degrees. So what's left here? If you're walking this way, then left would be this way, right? That's your L thing to the left side. So then you do 30 degrees based on this straight line. So it's just 30 degrees here. And then that's again another 10 centimeters. I believe that's at 1.8. Well, I'm gonna link A, B, and then I can C. Then it's gonna turn another left 70 degrees. But it's gonna turn 70 degrees now from this one. Right, and again, we're now walking to the left. C. And that's one. So now we're gonna go on and solve the rest of the problem. It asks us to solve the x-y components of the ant's average velocity. That means it's asking for the result of this line right here, right? We added it, scaled the tip, climbed them up. But we still need to find the x-y velocity. So the way you would do that is find the velocity for each vector. So we have A, BA. Remember that B is equal to delta X. So delta T. That means that our BA is equal to delta X times 3. Yeah, you guys can. Over 2 seconds. I'm going to get in centimeters because when I solved it in meters, there were a lot of decimal points and that was for 1.87. And then you see is 1.5 centimeters for 1.55. Centimeters per second. 2.5 is 6.5. Yeah. It's 6.45. Have 6 things here. Okay. I technically this will be 1 and I could go with whatever there has a small point to be honest. Anyway, from there we're getting dagger theorem, right? That looks like this. There's a right angle here. But if you're doing x and y, then you're gonna have a right angle. And then this is gonna be half of the h. Right. So the Pythagorean theorem looks like this. A squared plus b squared equals c squared. Right? Where this is a, this is b, this is c. So we're just gonna turn that into x squared plus y squared equals to h squared. Right. So we're trying to find h, and that's going to be this using the x and y components from our little ant walking. So we're trying to isolate h. So to do that, it's kind of easy in this method. Just kind of square root everything. Then I can do which is the square root of x squared, and then you're going to plug that in. But you don't have the x and y to do. So we have our A. Because it's a straight line directly on the axis, you know that there's only x for that one. Because it's the same as like angle 0. So the x angle, x is meters per second. And who's right, B, Y, circle. Meters per second, just for the sake of it. Then we're gonna go and solve BP. BP looks like this. We have our 30 degrees from the x-axis. So for this, we go to the opposite from our angle. This is the adjacent triangle. So then we're going to sine. Opposite of our hypotenuse. This is our B. Their hypotenuse. I should probably use R over here because there's a vector. Oh, you guys don't get it confused. Opposite of the hypotenuse, this is our x, their y. So then that's the y over the d. Again, you're gonna multiply out here, sine theta. To the y over the d, multiply both sides by d. You can use out. That means that maybe and you're going to do a similar thing to this A here. So we have cosine theta. We go to it based on our topic. We go to the x over the b. Multiply it out. Theta will be x over b times b, and multiply it on the side. So then that gives you cosine theta is equal to b. Here we're going to again for C. But this one you're going to need to add the angle a little bit. Because if you're using reference to the x, this one's gonna change, right? Because for the C angle, you had for the C angle, not like this. You had from the x-axis, you had this initial 30 degrees. And then you had another 70 on top of that. So then your total angle is going to be 70 degrees plus 30 degrees, which should be like 100 degrees, right? So we're like, okay, that's a kind of big angle, and you can definitely use it like that. I like to go with the smaller angle. I'll go both ways to do that. So we can use it as angle expression is 100 degrees. Or alternatively, you can do they're 90 degrees. That you can use minus 90 degrees plus 10 degrees. The alternative, you can do 10 degrees here for your B. Now the difference is whether or not you add a negative after you're done. So for this one, you're not. You're gonna go, okay, the opposite is probably the one. I'm gonna do the first one. So you have your Y version. You see for your x, we're gonna have opposite, which is sine. You know, opposite over hypotenuse, which is at this moment BCX. over BC. Again, you're going to multiply both sides by BC. So theta, zero to BC x. And then for your y, yes,
Yeah, you guys.
the cosine. So we get our hypotenuse. Because the adjacent point is y, it's going to be BCY. BC, you're going to multiply both sides by BC. Then you're going to be left with BC cosine theta equal to BCY. I'm just using the subscripts there to keep track of what variables what. Dr. C will do that as well. Now we're going to plug it in. First, we're going to determine whether or not it's positive, right? For your y, you're going to positive direction, so you know it's going to be positive. But for your x, you're going this way, and we have to find our axis. We have to find our axis as upward is positive, that way it's positive, this way is negative, and downward is negative. So this is coming this way, meaning that your x is going to be negative. So you're just going to mark it as negative. See the that's what we have right now. And this is going to be positive. Or right. I know that we can still do like this is positive, so they're both positive, but because we're still going off the x, we don't need. And solving for C as well. Oh, Bx is going to be So if you plug this one in, you get 6.35. And this one you get 1.12 computers per second, but because we determined that it's the x direction, we're gonna add that negative. If you're adding that, you're not gonna get that. So then that's one way. This one, I don't know that much, but I want to say that your adjacent is still gonna be your x, because it's down here. And then
I'm gonna just pause this.
so I actually don't know the logic all that well, because the way I combine my opposite and adjacent kind of relies on this right angle here, and having that clear theta. But I plugged them both in the calculator. The cosine will give you your x value, while the sine will give you your y value. Your positive 6.355. They did get the same value, so you can definitely get the right answer. I believe it's because it's your angle, so the adjacent one would be your x here, which would be your cosine. And then it can't be. See, in my head, it's with the hypotenuse, but it's not across the right angle. There is no right, which is why I've never used it that much. So I would probably use an online based over me for this, but you definitely can get the right angle from this, or you can ask me to put it up and I will try to do it as well. Continue on problem. That gave us our BCX and BCY. BCX is negative 1.12. Remember, it's negative, even though the sign 10 gave positive value, we know that it's going in the negative direction. And our BCY is 6.35 meters per second. So from there, we can take all of these values and add them up. So for the VX, sigma VX, sigma means sum of. Right, VX plus our VBX plus our VCX, and so on and so forth. So we do. So you have 0.5 meters per second plus 1.2 meters per second plus 2.3 meters per second. Now, later, and then sigma VY. Be a y, so be x y, b by plus b c y. But you know this be a y 0. I'm going to write it to get to it. The by is 2.8. And then we see is negative 1.2. I know these problems are long. You can plug it into this equation in the top earlier, you can take that theorem. Then we're going to do the result of vector. Into the square root of EX. Squared. BY. Five, 8, 4 centimeters squared over second. Making the square root of that. To get 12.7 centimeters over second. The square root of it. So now we know the magnitude of our actual velocity. Now we need the direction. You know, visually that's heading up in this direction. So it makes sense that the v and x, dx and vy are positive. They're positive direction and positive direction. But we still need to find the angle. And for that, we're going to turn to trigonometry. Make sure you guys can see.
Yeah, you guys can see.
So at SOHCAHTOA, you saw that sign. Opposite over button. Sign. Base and order button. Tangent. Opposite over base. Right? If our triangle is opposite. Jason. Cool. So because we did solve for the result vectors velocity first, we can really use any of these. Just remember that this O is going to be Y, this A is going to be X, hypotenuse is going to be a resultant vector. However, if you didn't solve for this one first, the only one that you can do is tangent because you only have the X and Y. So we've done sine and cosine quite a lot already, so I'm gonna do the tangent version. So theta equal to opposite over adjacent, which means is in our case to Y the direction angle here. It's like they have not. So Y. But in order to find theta, we need to use either arc tangent or tangent -1. So, all right, go for it. You can see that part?
Oh, you can't.
We have arctangent and tangent to -1. They're the same. Usually you will see arctangent types and tangent -1 in your calculator or in the. It's because it's a lot easier to type of arctangent. So this. Awesome. So then we're gonna do the inverse. I clean up what's small and change it over. Or no, it's the anti. Then you're gonna do. Arc tangent. Or. -1. Divided by dx. So then we're gonna put this. Nothing. 1 comes to be y, which comes to be 160. And then dx. About 9. So I'm going to find someone. Because they put 12.7 centimeters, but it won't be correct, we're going to convert it over to meters. So I'm going to change that. Make sure to go back on 2. It doesn't plan to go back on 2. So then that gives us 0.127 meters. You can convert the beginning or at the end. It doesn't really matter. I did at the end because honestly would have taken a lot of work to do all of that. Cool.
Yeah, one more. Now I'm going to share my screen. Okay. All right, we're gonna work on this one next. Take a look at it while I erase the board. so that you've taken a good look at it and maybe tried it. Go back to oops.
We have a batter. It's a baseball. Projectile motion. We're gonna pretend that he hit it from the ground, because that'll make things easier. We are sometimes going to write it. Right? So it gives us P naught. P naught up to 37 meters per second. Right, and then we can also assume that x naught equals 0 meters per second. Right, 0 meters, and y naught equals 0 meters, and p naught equals 0 seconds. We can of course make these assumptions without writing them out, but it's better to write them out. That way, anyone who looks at the problem knows where you're at and why you need that. So the first thing we need to do is find v naught for x and y components. That's that one here. We have our v naught. We have our theta here. It's an angle. And it's going to be v naught x, v naught y. Right, so we see right here, okay, so the opposite sign, that's going to be so sign. Sign theta is going to be naught y over v naught times v naught over times. Opposite over. I don't think I need to explain that. And also run the turnaround time. So then equal to v naught sine. And we have a v naught x. You know that's our adjacent, so cosine takes our values. So cosine theta equals v naught x over v naught on both sides. So that means that v naught x is v naught cosine theta. So I'm going to talk these right here, right now. Or put in the equations. It's usually better that you put them directly into the equations so you don't have as many numbers. So we have to solve as a thing. Then run it. So then it asks for the position. For position, that means you're going to use x equal to x naught plus v naught x t plus 1 over 2 as u squared. Right? And then for y value, we're going to do y, same equation, but with y instead of x. Not y plus 1 over 2 ay squared. We're gonna know that this one is zero, right? There's no acceleration for x. However, this one's gonna be gravity. Gravity goes downward, and we're defining this as their axis. We're up, and that way positive, gravity is going down, so it means it's negative in our axis. We said x naught and y naught as 0, so we will those out. Which leaves us with our equations. y equals to v naught y. If I put writing. I'm just plugging in. Over there, where the y was sign. And the x cosine. Right, because we solve those over here. And we can plug all of that in. So v naught sine theta plus 1/2 times negative. I think it's 9.8. She usually won't give that to you, so I do recommend having it. We get it, she did so much that I would, but I don't remember. Plug in what we found over there, x. Put it in not. It's. And then that's it. We don't have any initial starting point and we don't have any destination. Cool. Then I asked to find out at times two sections. We can do that later. Right now, I'm just gonna derive to get the velocity. We have e equal to 3x over dt. We're going to divide this x into b, being not cosine theta times 1, e to the 1 minus 1 to 0, 1. Then you just have that. Our y is a little bit different. We're still going to have this cancel out. I'm not going to problem. So that's 1. And then we can divide. I think 3 to 4.9 like that. Yeah, so we have this 2 come down, times 1, and 2 times 1 over 2, times negative 9.8 squared, t to the 1 power. These 2 are going to cancel out, and that leaves you with gravity with speed. I'm probably going to look at the gravity. You don't have to write that until you're ready to focus. I just have it. I don't think it asks for acceleration. No, it doesn't. So then that's as far as we need to go with the drive. Now we need to find that 2 over 2. Let me draw. So x 1, 2, 2, which would be not 37%. Cosine theta. Theta is 53.1 degrees. Theta times 2 seconds. And then we'll do dx. Notice that this dx is a constant. There is no t variable, meaning it's not going to change this time. It's just going to be what? Plus a negative. So this expectation 44.42 meters. This y is 39.58 meters. Y is 22.2. Nine point nine. Now we need to find the direction. These problems start for so long. So these are our magnitudes for the x. I need to ask to find the magnitude direction of its velocity. So, sorry, these are the positions. They're my positions. I'm going to find the magnitude velocity, which we're going to do that. Go squared into x squared plus y squared, which is Pythagorean theorem is really the way. Square root of creating the b's, so yes, this would be 2. Y is 9. That is 24. Then we need to find theta, or yeah, theta. And 10. Theta. In this case, we've got positive x, positive y, positive x, positive y, and it's minus so then that means the opposite person thing it could be y and then you can x. And you need to go 1. One, y, yes. Theta. One, y was. Yes, two. So I can just. Maybe a little square here. And then fill it in. I don't feel like making that. You can also, sorry, since. Anyway. Velocity, that's position. Then we need to find the time and bottom of the highest point of the flow. Okay, so we know the highest point is up here. Right. We also know that right there, we have v equals 0. Because it's changing from going up and coming back down. It's the same as free fall. And then we also know that it's symmetrical. So whatever is on this side can be on this side if it's the same like this minus tree. So find the time for the highest point. We're probably going to use the Vy. Takes. I'm going to erase that. Let's try to take screenshot. So it's not totally that is 0 Vy is falling in the line. It's just that Vx. Then that Vx. It's constant. Totally crazy. I have 2.2 meters. Right, that's fine. There's no other playing into that. Then we can use the Vy. Plus minus gravity into gravity. Now we know that this is 0 at highest point. So then that means you have 0 equal to a naught sine theta. Which can be rearranged in would be naught sine theta. And you're solving for t given by the max height is not in now 7 seconds. Sine over and positive now. Practical time take that's 2. I got 3. Probably 3.72. just so that it's not too awkward. And then it asks, find the height that you choose. And you're gonna use your y equation for that. And you're just gonna plug t in for it. If y is equal to b naught y t plus 102 ay gravity. To gravity t squared. You can plug in y 3.02 seconds. B naught y is 37, so B naught y is sine square of your time. Y at 3.0 got 44.7. And that solves E. I need to find E. Find normal to this starting point, the point which is bottom to ground. So that's this X. How do we do that? Well, we know that it's E here. So we know that it takes 3.2 seconds to get here. Then it's gonna take another 3.2 seconds to get back. So get to the top. It's going to take the same amount of time to get to the top as it does to get to the bottom, because only your x is constant, your dy is linked to by acceleration. So it's like a control problem with direction. So then we have to I think that's a basic over. Put that in. I know we erased our equation, but it should be normal. Normal is not, we don't have squared, so it should just be the not x cubed, which is the same as p not x, same as p not cosine p naught. So cosine should be 130 134.2 meters. That comes off the problem. It's not going to follow the progression to show the trajectory of the y components and the acceleration. It's asking you to draw two rows of acceleration. Make sure that you draw this part, we have the x and y components of the v naught. And then make sure you show that the speed naught, v here is 0, and then you start your vx, and then your time there. It's time. And with that, I hope you guys have a good weekend.
Take care.